I'm Will Arroyo. I'm a solution architect within VCF. I'm going to walk through kind of deploying applications to VKS, not just applications though. So kind of be a flow of what it's like for a platform engineer to build a Kubernetes cluster that's ready for an application to be deployed on, and now as well deploy an application. So it's going to combine kind of two personas really, an app developer and a platform engineer. Just a couple slides before I get into a demo. So Timmy talked about this in session 1, and I just highlighted some of the services that I'm going to use here for the demo, which is the VKS service, so the Kubernetes service. The underlying infrastructure services are kind of just there because like they're core components to building a cluster, right? I need a load balancer, I need some storage, I need networking, all of that. And then I'm going to add some cloud services. So I'm going to deploy Cert Manager, also Argo CD. So Argo CD is going to be used in this flow for not just like, we don't want to just create a cluster. We actually want to bootstrap that cluster with a number of components inside of it. So we're going to combine kind of a Terraform workflow plus an Argo CD workflow. Then on top of that, there's some standard packages. So I didn't highlight anything on the bottom because, as Timmy mentioned, those services are kind of auto-deployed. Like these are things that we need in a Kubernetes cluster for the Kubernetes cluster to be functional. The CNI, we have some other things like Pinniped for auth and stuff like that. But on the top, I'm also going to be deploying Prometheus, Telegraf, Istio, external DNS, and Cert Manager so that my application has ingress when it comes up, so that monitoring is already kind of wired in for us out of the box. External DNS so that I get a host name, and Cert Manager so that all these components can get certs and things within that. So those are kind of the core components that I'm going to be using from this stack. I'll pause there for any questions so far. That makes sense to everybody? Cool. All right, and then just before I jump into it, talking a little bit about APIs, because I'm going to be using Terraform here. That's not the only way to consume these things. Timmy mentioned it. We'll talk about it in the third session as well, but everything going through kind of VCF and the consumption interfaces here are going to be declarative APIs. So you can consume those with kubectl. You can consume those with Terraform, Ansible, GitOps through Argo CD, all these types of things. So I'm going to show kind of one way of doing this. But if there are questions about, hey, can I use this tool or could I do this thing? Just ask. But I'll try and call out like, hey, you could do it this way as well. So this slide just kind of highlights those different APIs and the ways that you can consume them, through catalogs. So for some folks that have come from using VMware for a long time, there's this concept of blueprints and like a self-service catalog. Those catalogs can be used to generate Kubernetes resources that deploy things like Kubernetes clusters. So you can still use that flow. You can also use a declarative API directly, right? That's things like kubectl or GitOps and those components. And then there's Terraform as well. So Timmy mentioned it also, but because these things, these objects and the services we're deploying are Kubernetes resources, the Kubernetes Terraform provider works really well for that. There's also some other providers that provide access to different layers within that API. But really the main point of this is that like whichever way you're coming in to consume this platform and how you are comfortable as a platform engineer, the API is flexible for how you want to consume it and use it. Any questions? Cool. All right, let's get into the demo. I usually do live demo stuff, so I've recorded this just to make sure that there wasn't any Wi-Fi issues or anything like that. So we'll run through it. All right, so what we're looking at right now is I'm kicking off some Terraform. So I'm going to run a Terraform apply, and I'll talk through what this is going to do, but this is the only command I'm going to run this entire time in the demo, right? So it's going to say, hey, I'm going to create a bunch of resources. I'm going to tell it, yes, I want to. Try and remove that thing. There we go. And what we're looking at above, I'll start to go through as well, which is the actual code for this. So this is going to go create essentially a supervisor namespace, an Argo CD instance. It's going to wire that namespace back to Argo CD. It's going to create a Kubernetes cluster using VKS. It's going to attach that cluster to Argo CD. It's going to bootstrap that with a number of core applications. So things like Istio and all those packages that I was talking about. And then it's also going to deploy an application. So you can see I'm kind of putting a bunch of these pieces together. Probably in a more enterprise workflow, you'd separate out like the core underlying platform engineering components from the actual application deployment. But just to kind of simplify that for a demo purpose, I've put the application deployment in here as well. So that's what's essentially happening when I run Terraform apply here. And you'll notice that I had a few modules within here, so I'll dive into one of the modules behind the scenes, which is going to be the cluster module. So the cluster module itself is just, I'll pause it there. This is just using the Kubernetes provider for Terraform, right? And you'll see the YAML in here looks very similar to this isn't YAML, this is an HCL representation of YAML, but the YAML that is defining this is basically just a Kubernetes CRD that is a cluster, right? And this is what you saw in the UI that Timmy showed. I'll show it here in a bit. But that YAML can be used with Argo CD, can be used with Ansible, again, Pulumi, all these different tools of how you consume an API. And really, I think kind of one of the main pieces around that is customers, enterprises, organizations, all these have the way that they consume infrastructure. They don't necessarily want a new tool that's like, hey, you brought your new orchestration tool in, we have to use that. We want to be able to meet the customer where they're at with, you already have a workflow for how you provision infrastructure or how you deploy apps. Let's give you an API that's consumable in that way. So I just really want to highlight, I'm using Terraform here for this, and many people do use Terraform, but this can easily be consumed through any other infrastructure as code tooling. Pause there. Questions? Make sense? Awesome. All right. So from here, while this Terraform runs, I'm going to go jump into, this is just kind of highlighting again, kind of all the way down through all the settings that are available through this. So let's pull up a browser. We're going to go log into VCF automation. So I'm going to pause again. VCF automation was not, I don't think we really fully talked about it in the last session. But if you think about kind of like public cloud having a console that you log into, which all of them do, to go, access the UI for different services and all of that, think of VCF automation as that core interface of how you're going to go consume infrastructure as a tenant within that, right? So as your platform engineer, you're logging into this, it's going to give you the right permissions and everything you need to see kind of what you're deploying. So what we can see here is that a namespace has been deployed. It's that WWYVT namespace with a large namespace class. So that's what Terraform did initially. And a supervisor namespace in this case is kind of a construct within the VCF platform that allows you to separate out where you're creating other services. So like the VM service, the Kubernetes service, those components, Kubernetes clusters and virtual machines, can get deployed into a namespace, and that's kind of a tenant boundary. It defines networking boundaries, it defines quotas and things like that. So as a platform engineer, you can come in and you can say, hey, I might want to give out namespaces to dev teams, and then you can quota them within that so that they're not consuming all the infrastructure. Or you can self-service this out. So it gives you some flexibility.
These are not Kubernetes namespaces. These are...
So great question. Great question. It comes up a lot. So one of the backing components here is the supervisor cluster. That's kind of the management control plane because, again, all of these APIs are Kubernetes CRDs. We need a Kubernetes cluster to reconcile those, right, as the API.
It's like a utility cluster.
Exactly. Yeah. Management cluster kind of be considered. So this is a namespace within that supervisor cluster, that management cluster. So it is a Kubernetes namespace, but it also has a connection into vCenter behind the scenes that uses essentially a resource pool to quota that infrastructure. So like you've got actual physical hosts as ESX hosts, right, that have your compute. And when we deploy a supervisor namespace, we can allocate some of that compute to the namespace. So it shows up as a Kubernetes namespace, but it's also backed by infrastructure quoting to say that if I deploy a cluster into that namespace, maybe I'm only allocated 60 gigs of RAM or something like that, right? And it will prevent you from going over that.
Right. So how does that then, that's a great segue into my next question, which was about resource limits. Are there some automations in here that help platform engineers or the operations folks determine appropriate resource limits? Because the worst thing you could do is not put any resource limits and then just tear the whole thing down every time you run something.
Absolutely. So the namespace class concept that's kind of sitting here, those are predefined. You can define as many as you want, and they define memory, storage, and CPU limits that you can put on that. So you can say, like, maybe a dev team's coming in that has a really big workload. Okay, we're going to give them an XL class, and then you can scale that up and down. And
as a platform engineer, do you warn me if I've got too many extra larges deployed into one spot?
Yeah, you can see kind of like an overall. I can probably. I was going to jump to my live environment. I'll show that maybe here in a bit. But yes, you can see like the total consumption over that to make sure you're not bumping up against limits and all that. And then also, because we're surfacing all these metrics up into VCF Ops, you can also set up alerting and things there to say, like, hey, we're really hitting close to the limits on this environment and stuff like that. So, yep. Let's see here. Okay. After we kind of look at the namespace, we'll also look at what's deployed here. So I'm jumping into the namespace now. So I've gone into a project, I'm going to that namespace, and we'll see kind of a high-level view. I've got a Kubernetes cluster deployed, and we can see that that is the actual cluster that's currently being deployed by Terraform, but I'm looking at it from the UI perspective now. And within that, if I open it up, we're going to get a number of details about it. I can see the YAML for what's deployed. Again, because this is a Kubernetes resource, this is what the actual live cluster manifest looks like. And then within that, let me see, I think I scroll down. Okay. Just make sure I'm going to the right place. Okay. It looks like the Terraform completed. So from here, we're going to go look at, there we go, sorry about that, recorded demo. So this is going to show creating a cluster. Timmy showed this, so I'll just touch on it a bit because it's only like 20 seconds here. But I'll talk about something slightly different, right? So it has the YAML on the side. Timmy talked about these kinds of things, but what I want to highlight is because we're using Kubernetes behind the scenes for these cluster deployments, if maybe I'm not comfortable with GitOps yet, maybe I'm not comfortable with Terraform or something like that, I can come in, I can create a cluster through the UI, and then I can eventually move to managing that with GitOps or something like that. Because that cluster state is behind the scenes inside that supervisor cluster that I was talking about, you can go edit that directly on the supervisor. You can adopt it with Argo CD. You can manage it through the UI. Now, obviously, if you try to manage it all three ways at the same time, you might end up with some conflicts. But the point is that you don't have to say, I'm going to go delete my clusters so that I can start using Argo CD or something like that, right? Okay, so let me jump back a little bit here. Within this, okay. The next piece of this is going to be that after this gets deployed, it's going to be automatically attached into our cluster management. So within cluster management, this has some things like policy. So what we're looking at now is I have a project. That project is a tenancy boundary. My cluster got deployed into a namespace within that project, and I've set up some default policies within this. One of those policies in this case is a restricted policy. I put it in audit mode just so it doesn't block anything right now. But that's some default admission policies. So block privileged containers, block network, node network, all that, host network, all those kinds of things. So when a cluster gets deployed in this project, it's automatically going to inherit that because we're also deploying Gatekeeper automatically into those clusters. So you're getting this native policy, and you can do other policies in here like custom policies with Gatekeeper and OPA, image registry policies, all these kinds of things can happen through this. But I'm not having to deploy these policies on every single cluster. They're being inherited kind of at the fleet level, so that a platform engineer can set these up ahead of time and not have to worry about like how they get applied or if they're going to get applied. Does that make sense? Any questions there? Good. All right, so this is just showing kind of a look into that policy behind the scenes. We can see that there's some insights that are being shown. This is a different insights view. So it's actually going to surface up all those violations. So if I have it in audit mode, for example, I could go see all the clusters that are failing for specific reasons, and then go maybe apply more strict permissions. And then just a high-level view of what you're also getting at the fleet level is a view into that cluster. The nodes, high-level visibility on how much resources are being used, the namespaces, the resources within that, and so on. So that's just a quick kind of view into that fleet management concept there. So if we go now look and see what else was deployed with this, Argo CD in this case was also deployed. And I'll touch on this for a minute because it's important about how this got deployed. Argo CD in this case is a cloud service that we provide, meaning that this is deployable, not just a single Argo CD instance, but you can consume it on demand, right? So within that namespace that we deployed, I also deployed an Argo CD instance using a Kubernetes CRD. So essentially just a small amount of YAML that said, go deploy Argo CD into this namespace. That could be namespace scoped. Depending on how your organization is set up or something like that, you might have a centralized Argo CD. You might want to do them per team, something like that, but you can consume those however you choose because, again, this is just simply deploying a Kubernetes resource within your namespace. So Argo CD was deployed, and then what we do here is we wire this up to not only the cluster, but also the namespace. So these two clusters that are now part of Kubernetes, or part of Argo CD, are the VKS cluster we deployed, as well as that supervisor namespace. So now I can use Argo CD to deploy more clusters if I want. I can use it to deploy load balancers. I can use it to deploy VMs. All those types of things can now be done through Argo CD. And I can also deploy applications to the clusters that I deploy with Argo CD. So it gives me a bunch of flexibility in being able to control everything with GitOps if I want. Pause there. Questions? Yeah.
A little unrelated, but I haven't heard anything about OpenSSF or SigStore. And so since you're talking about Argo CD and you're the application deploying that, how much of that is out of the box, or is that something you have to go back to the Tanzu version versus V?
From a SigStore perspective?
Well, starting with OpenSSF, like in other words, sort of signing of images, the artifacts, the process of making sure that all that. I didn't see anything in any of the images that imply that's out of the box.
That's correct. So from what we're doing here doesn't really involve the, let's call it like that initial portion of the supply chain of like building the images and those components, right? That was a component of Tanzu. Right now in the VCF stack, there's not like an out of the box, let me go build a container for you. Tim, you might want to jump in here as well too.
Not to be, but that's pretty important, right?
Yes, but also I would say that a lot of customers already have those things, right? On how they're building their images. But Timmy probably chime in.
We feel that a lot of our customers have parts of this area figured out. But one service we do ship as a part of our stack is our registry service, which is built on top of Harbor.
Well, okay.
And Harbor does all kinds of things around, image management. Like we can, we can do a great deal of work there.
Not the Harbor on this subject, but the point is, how much integration do I have to do as a client? Because you supply so much in this architecture, but then it sort of scares me a little bit that I have to do a lot of extra legwork. Like you say, oh, the customer does that. I'd want you as my provider to give me that sort of out of the box. I want OpenSSF like glaring support from day one.
Yeah, absolutely. And what we're doing is we're working on, extending each of our services as a part of our cloud.
Okay.
Out of the box today, we have our registry service, which can help complete part of that story. And we'll probably look to extend that over time.
Okay, cool. Thank you.
Right. Okay, so kind of moving along in this demo, you'll see that there's a bunch of stuff deployed via Argo CD. All of this was bootstrapped through that Terraform deployment. So we deployed essentially I'll pause it really quick. We deployed an application set, which is an Argo CD concept, and it installed some ingress, some observability, kind of all those things I was talking about. So all of those apps just showed up automatically. And then also we deployed the music store app, which is what we're looking at here. So again, kind of combining both the platform engineering components of this, which are installing Istio, cert manager, external DNS, and all of those pieces, so that when we actually go to our app, we get a URL, we get a DNS name, and we can actually go to our app directly here. So with all of that, essentially a Terraform apply, it created everything and installed the ingress, it wired up DNS, it deployed the application, all of that in a few minutes essentially while the Terraform was running. Now, what we're going to do now is jump back kind of into VCF automation and take a look at some behind the scenes. So one of the other things that I did here is created an IaaS policy. So what this is utilizing the validating admission policy within Kubernetes, but within the management cluster. So I created a policy that's restricting to dev only. So within my project, I'm only allowing clusters to be created that have one control plane node. So for example, if this were a dev environment and I didn't want people spinning up HA clusters, taking up more resources and all of that, I can use the validating admission policy to block them from doing that. I can also write any custom validating admission policy to essentially manage or block any types of APIs within the infrastructure APIs. So if I'm creating a VM and I don't want to allow certain fields within that VM, if I'm creating another cluster and I only want to allow specific VM sizes for that cluster, all of that can be kind of done through this IaaS admission policy through here. And then finally, the last thing I'm going to show, I'm going to jump over to a different cluster that was deployed and look at the integrated observability pieces. And I chose a different cluster here because it's been running for longer and it has a lot more data to see than one single bullet point. But again, from kind of that core cloud console, I can go in, I can click on my Kubernetes cluster, and I can see all of the metrics surfacing from all the pods, also all the virtual machines that make up that cluster in a single view here. And all of this is automatically being streamed back from those clusters after they're deployed. So you get really kind of like a full out-of-the-box experience of deploy a cluster, use Argo CD to deploy apps into it, and then get kind of the visibility back into it as this goes through. So that is kind of the full...
I have a dumb question.
Yeah.
Guy Courier Future. So this is in VCF.
Yes.
But this is using the vSphere Cloud, vSphere Kubernetes Service.
Correct.
But whatever else I'm doing and deploying and managing is going to be in VCF as well.
Yes.
Right.
So
my question is for an operator. So Mars and Venus and all that, like the frequently these are different teams or single platform though. What are you doing to enable at least cross visibility or cross pollination?
Yeah, great question. I think the easiest way to say that is within the platform itself, right? So when we think about VCF as a whole, we think about like these different layers, and it might be easiest just to kind of draw some of this out, right? So you've got like VCF-A here, which we were just using, and then beneath that sits kind of like your core vSphere stack, right? The traditional components of this, ESX and all of that stuff, right? And then you've also got components like VCF ops that sit within this, right? So these different components all have kind of a tenancy model and a persona around them. So as a platform engineer, I'm going to be logging in to VCF-A, and I'm going to have specific roles and permissions that allow me to do what I was just doing, right? But also, as a cloud engineer, let's call it, I'm going to be logging in here as well. So I'm going to be able to see the same components. I'm going to be able to set those quotas. I'm going to be able to set those boundaries. But I also am probably going to be logging in further down the stack to set up core networking, compute, all of that stuff. And then I'm going to surface all of that stuff up into ops. And when I deploy clusters, which land kind of...
Is there a missing arrow there between VCFA and what's VCFA again?
VCF automation.
Automation, okay.
Yep, so yes, that arrow there. So those metrics and things are going to flow into VCFA, and then you're going to have, you know, your VKS clusters that are deployed that land on this that are also going to be surfacing up information. So really kind of like, I think to answer your question maybe, is that we're giving different roles and permissions from a tenancy perspective through kind of the cloud console, which is VCF automation in this case. And then we're surfacing metrics and the visibility components up through VCF ops and then back into VCF automation so that the people who need to see the things that are going on can see them. And then the permissions of who needs to control different components, like who can create clusters, who can create policy, who can do all of that, is also controlled through those boundaries within VCFA. So I hope that's kind of...
So from a management and strategy architect's standpoint, seems to me you can get a lot of unified reports about the whole state or the whole domain or what have you. But also from the operator standpoint, you can also be somewhat agnostic, but it does seem like there's a little bit of context switching from that standpoint involved. Maybe that's inevitable given that there are two different platforms or three.
Yeah, I mean, there's definitely differences, right?
Well, you can sit there and drag application out of this VM and into that.
You still have to be context aware, yeah.
So something like, and I'll talk a little about this in the next session a little bit, but a key thing here is that we have these personas, but the personas are, if you think about the public cloud, you have a hidden layer that's responsible for like the magic that's happening in the cloud. And then you have everyone that is consuming it. They're all consuming it through the exact same interface.
Yeah.
But based off of their roles and their access determines how much they're able to see, how much they're able to like flex in that space. And that's exactly the model we're going with here is VCF automation becomes that cloud portal. It's where all consumption of the infrastructure actually occurs.
Just the sort of elephant in the room, right, is sort of like Claude Code and CLI-based implementation. I mean, we're not hearing any of that right now. Maybe that's on purpose, but it seems like the momentum shift of administrator now is almost 80-90% going to, CLI-based, like Claude Code or Gemini CLI or those type of things. I kind of expect to hear a little bit of the narrative there because, GUIs are sort of...
Yeah, I mean, so like we talk GUIs here, but really that...
I saw the Helm stuff, but I do think it would be interesting to hear more about how I would sort of do all the stuff you're talking about, like Claude.
Absolutely. So we'll talk a little bit about that experience
in
the next presentation.
Thank you. Okay.
The last thing I want to touch on here is just kind of this diagram. This is what just kind of happened, and I just want to show the architecture of it to kind of put the pieces together, right? Is that we use Terraform to talk to the VCF API. Again, that's kind of that centralized API, exposing a Kubernetes API with CRDs. We have cluster management running in there in our IaaS policy. We deployed a supervisor namespace. Argo CD was deployed into that, as well as a VKS cluster. We then wired Argo CD up to that namespace, as well as to that VKS cluster. We deployed our apps through Argo CD, so like our core ingress, observability, as well as an application into that VKS cluster, which resulted in Istio, external DNS, Prometheus, Telegraf, Cert Manager, the application itself. And then cluster management is managing things like Gatekeeper and Valero in that cluster for us. So all of this kind of happening in that single deploy. And then just to kind of round out that full picture, I'll just draw this down here, right? Because I think there's been maybe a little bit of confusion or questions around like, where does VCF land here? So if I just draw a big VCF box under this, what I really want to change this to is like, this is your data center and your infrastructure. This is like, if you're using vSphere, this is NSX, this is ESX, this is all those kind of underlying components. All of this is running on top of that and utilizing that.